MVDC HiPot, or High Voltage Direct Current HiPot, applies a high voltage direct current to the insulation system to test its resistance to electrical breakdown. It is more sensitive to insulation defects than AC HiPot due to the constant voltage applied, and it is suitable for testing high voltage electronic devices. However, it requires specialized equipment and expertise, and it is more time consuming than AC HiPot testing. AC HiPot with tan delta technology applies alternating current to the insulation system while measuring its capacitance and dissipation factor, also known as tan delta. It offers a fast and efficient testing process, detects insulation aging and deterioration, and can be used for online condition monitoring. However, it is less sensitive to certain insulation defects compared to MVDC HiPot, and it may not be suitable for testing all insulation types. Considering the pros and cons of each method, MVDC HiPot offers high sensitivity and suitability for electronic devices, but it requires specialized equipment and is more time-consuming. AC HiPot with tan delta is faster, detects aging, and allows online monitoring, but it is less sensitive to certain defects and not suitable for all insulation types. The National Fire Protection Association, or NFPA, website provides information about the National Electrical Code, or NEC, adoption by each state, available at NFPA. org/codes and standards/all codes and standards/list of codes and standards/national electrical code/NEC adoption information. The MVDC HiPot method applies a high voltage direct current to the insulation system of a device or cable. The purpose is to verify that the insulation can withstand the intended voltage levels without breaking down, which could lead to equipment failure or safety hazards. During an MVDC HiPot test, a direct current voltage is gradually increased to a predetermined level, which is typically significantly higher than the device's normal operating voltage. This voltage is then maintained for a specific duration, often several minutes. Throughout the test, the current flowing through the insulation is monitored. If the insulation is in good condition, the current should remain very low, indicating high resistance. A sudden increase in current or a breakdown in voltage indicates a weakness or fault in the insulation which needs to be addressed. Advantages of MVDC HiPot testing include its sensitivity to insulation defects. Due to the constant voltage applied, it can detect subtle flaws or weaknesses in the insulation that might not be apparent with other testing methods. It is particularly well suited for testing high-voltage electronic devices. Some disadvantages of MVDC HiPot testing include it requires specialized equipment and trained personnel to perform the test safely and accurately. It can be more time-consuming compared to AC HiPot testing, especially for large or complex systems. AC HiPot testing with tan delta technology applies alternating current to the insulation system. This method measures both the capacitance and the dissipation factor, or tan delta, of the insulation. This provides a comprehensive assessment of its condition. In AC HiPot testing, an alternating current voltage is applied to the insulation system. Simultaneously, the test equipment measures the capacitance, which indicates the insulation's ability to store electrical energy, and the tan delta, which represents the energy dissipated as heat within the insulation. The tan delta value is a key indicator of insulation quality. A high tan delta value suggests that the insulation is aging, contaminated, or has other defects that cause increased energy loss. Advantages of AC HiPot testing with tan delta technology include it is a faster and more efficient testing process compared to MVDC HiPot testing. It can detect insulation aging and deterioration over time, allowing for proactive maintenance. It can be used for online condition monitoring, enabling continuous assessment of insulation health without interrupting operations. Some disadvantages of AC HiPot testing with tan delta technology include it is generally less sensitive to certain types of insulation defects compared to MVDC HiPot testing. It may not be suitable for testing all types of insulation, particularly those with complex electrical characteristics. When comparing MVDC HiPot and AC HiPot testing with tan delta technology, it is important to consider the specific application and the type of insulation being tested. MVDC HiPot testing is often preferred for its high sensitivity to insulation defects, making it suitable for critical applications where reliability is paramount. AC HiPot testing with tan delta technology offers a more comprehensive assessment of insulation condition, including the detection of aging and deterioration, making it valuable for preventive maintenance programs. The choice between the two methods depends on the specific goals of the testing program, the characteristics of the insulation being tested, and the available resources and expertise. The NEC is a comprehensive set of standards and guidelines for electrical installations in the United States. It is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. The NEC is not a federal law, but it is widely adopted by state and local jurisdictions as the basis for their electrical codes. This means that electrical installations must comply with the requirements of the NEC in order to be considered safe and legal. The NFPA website provides a comprehensive resource for tracking the adoption of the NEC by state. The website includes a map showing which edition of the NEC has been adopted by each state, as well as links to state-specific resources and information. It is important to note that the adoption of the NEC is not uniform across all states. Some states adopt the latest edition of the NEC as soon as it is published, while others may take several years to adopt it or may adopt an older edition. It is essential to check the specific electrical codes in your jurisdiction to ensure compliance. Here are some additional details about each testing method. For MVDC HiPot testing, the direct current voltage is gradually increased to a predetermined level, typically 1.5 to 2 times the rated voltage of the equipment being tested. This elevated voltage stresses the insulation, revealing any weaknesses or flaws. The test duration is usually several minutes, during which the leakage current is carefully monitored. A low and stable leakage current indicates good insulation integrity, while a sudden increase or erratic behavior suggests a potential problem. This method is particularly effective at detecting pinholes, cracks, and other localized defects in the insulation. For AC HiPot testing with tan delta, the alternating current voltage is applied at the rated frequency of the equipment, typically 50 Hz or 60 Hz. The test equipment measures the capacitance and tan delta of the insulation. The capacitance value provides information about the insulation's ability to store electrical energy, while the tan delta value indicates the energy dissipated as heat within the insulation. A high tan delta value signifies that the insulation is aging, contaminated, or has other defects that cause increased energy loss. This method is useful for assessing the overall condition of the insulation and identifying potential problems before they lead to equipment failure. Both MVDC HiPot and AC HiPot testing with tan delta technology play important roles in ensuring the safety and reliability of electrical systems. The choice between the two methods depends on the specific application and the type of insulation being tested. MVDC HiPot testing is often preferred for its high sensitivity to insulation defects, while AC HiPot testing with tan delta technology offers a more comprehensive assessment of insulation condition. Both methods require specialized equipment and trained personnel to perform the test safely and accurately. It is essential to follow established safety procedures and guidelines to prevent electrical shock and equipment damage. In addition to the information provided on the NFPA website, you can also find information about NEC adoption by state from other sources, such as state electrical boards and regulatory agencies. These resources can provide detailed information about the specific electrical codes in your jurisdiction. It is important to stay up to date on the latest changes to the NEC and to ensure that all electrical installations comply with the applicable codes. This will help to ensure the safety of people and property. In summary, MVDC HiPot testing is a sensitive method for detecting insulation defects, while AC HiPot testing with tan delta technology provides a comprehensive assessment of insulation condition. Choice between the two methods depends on the specific application and the type of insulation being tested. The NFPA website is a valuable resource for tracking the adoption of the NEC by state.